Embedded software is what I do. At Royston Technology, I've had the opportunity to work with various devices such as smart card readers, three-phase amplifiers, even a smart toothbrush. I do a lot of work with ARM processors, but I also work with other devices such as Atmel's 8-bit range. The exciting thing about working in embedded software is there's always opportunities to work on new technologies and do things that have never been done before. I love getting things to work. I was recently writing a flash driver, which is quite a simple thing to do. It was an SPI flash. But I was having a problem because every time I tried to erase the chip, it stopped responding. So I tried a few things and I suddenly realised what was going on. The chip was resetting, but why was it resetting? Well, I had a hunch. The erase takes much more power than just the read. So I had a look at the schematic and realised that maybe it could do with a few more capacitors. So I Skyped the hardware engineer, we had a chat, decided that maybe I should add some. I added the capacitors, problem solved, everyone's happy. The interesting thing with embedded systems is everything's interconnected. So for me, it's not just about the software. You've got the hardware, the user experience, and the product as a whole. The products I work on vary, so it's important I make good decisions based on product requirements. That could mean using an OS, or sometimes not. The lower levels are normally written in C or C++, sometimes assembler. The higher levels, also often C or C++, but for some customers it makes more sense to use C#, Java, or a scripting language. Whatever I'm using, it's important that I embrace the philosophy of the tools. So if I'm using an object-oriented language, it's important that I make the most of that. Code is written concisely and is well commented. It will be optimized either for speed, memory usage, or low power, sometimes a combination of the above. Embedded systems can be very unforgiving, so it's important that I always consider all aspects of the product design. Testing is very important in embedded systems. We start at the lowest level with unit testing, which is automated tests which are written for each module of code as we're writing the code. As we join the modules together, we move on to integration testing. That proves the modules are working together. After that, we test the product as a whole in system testing. System testing, especially automated system testing, allows us to run long-term tests to prove that the product is stable. It often involves using a test rig. The ideas and sometimes the hardware used in system test can be used in production testing. Production tests are much shorter tests which are done on modules as they are produced in the factory. These are standard testing methodologies and they allow us to find issues before they become big problems. It's much more cost-effective to find a problem early than let it grow into a big problem. Thanks for watching my video. If you're making hardware and you'd like some software to make it work, I'd love to hear from you.